Body A of mass 4m moving with speed u collides with another body of mass 2m at rest. So this is 4m moves with a speed u, collides with another body of mass 2m, and this is having initial velocity as 0. The collision is head-on and elastic in nature. So since it is elastic, so therefore we have E is equal to 1. That means the velocity of separation should be equal to the velocity of approach. So let us say after collision they are moving with velocity v1 and 2m is moving with velocity v2. So in any collision, whether it's elastic, inelastic, or even partially elastic or inelastic, momentum is going to be conserved. So therefore the momentum conservation, let us apply 4m into u is equal to 4m into v1 plus 2m into v2. Con. So this becomes 2, this becomes 2. So therefore 2v1 plus v2 is equal to 2u. Okay, this is the first thing. Now E is equal to 1. So therefore velocity of separation, which is v2 minus v1 divided by velocity of approach, which is u. So therefore v2 minus v1 is equal to u. This is the second one. Now we add on. So 2v1 plus v2. So plus v2 is v1 plus u is equal to 2u. So v1 is u by 3 and v2 minus u by 3 is u. So therefore v2 is 4u by 3. Now what's the question? Fraction of energy lost by the colliding body A. So this was the body A. So initially it was traveling with velocity u. Now it is traveling with velocity u by 3. So initially it was having half mu square. Now it is having half into, of course, 4m. Half into 4m into u square by 9. So it was the kinetic energy initially. Now the kinetic energy is ke by 9. So therefore 8 by 9 is lost. Okay. So lost is equal to, which is 8 by 9 kinetic energy, which was initial. Okay. So therefore B is going to be the answer.